Hello friends, welcome to SQL with Manoj. Today we are going to talk about JSON feature in SQL Server. So JSON feature in SQL Server was introduced in SQL Server 2016. Prior to 2016, there was no option or there was no way to deal with JSON documents in SQL Server. Although JSON is nothing but a string data structure which can be stored in a varchar column or an nvarchar column, but there was no way to parse a JSON document back to a table structure, or there was no way in SQL Server to convert a table or a row or column structure to a JSON string. But starting SQL Server 2016, it provided these two options with some more options, right, to uh, convert a SQL tabular data into a JSON document. So we will check both of these options. First one is the auto option and another one is the path option. So auto option gives us an automatic way and a simpler way to convert a table to a JSON format. So we'll just check it out. I'll be using AdventureWorks 2019 database, and I'll take for I'll take this person table as a sample. Right. So first of all, let's see what all columns are available here that we can take for example. So okay, I will select okay, so I will select business entity ID, then first name, then middle name and last name. Okay, and I will just take okay, first of all, let's see how many records are there. Okay, so there are a lot of many records, around 19,900. So I'll take just a small set of records, top 3 records. Okay, yeah, this should be sufficient. Let's see how we can convert this into a JSON document. So with this query, you just have to use the for JSON option and the auto option. Okay, by just applying the for JSON auto option with any query, you can convert all these columns into a JSON document. So here is the output, and if you can click, it will give you output in a different window. But although it's not properly formatted, I'll take this to a parser. So I'll clear everything. Yeah. So if you can see, our 3 records are showing like this, as as these separate array elements, right? And this is a proper JSON document, right? And if you see, the middle name is not present at the end. We will see it going forward. Okay, how to handle that as well. Okay, so this is the very basic way to convert a table data to a JSON document by using auto option. Now let's see how we can customize this JSON document and convert it into a more nested like structure. So for that we have to use JSON path option, and for JSON path option, let's say we want the name in a nested structure. So what we can do is we can use an alias, that is, and within square brackets, name dot first name. Okay, and similarly middle name dot middle name, and similarly last name as name dot last name. Okay, so what it will do is it will just see that, okay, we have given this kind of structure, so it will group all these 3 columns under name. So it will nest all these 3 columns by creating a name wrapper. So let's see how it does it. So I'll execute this query, open it in different window. Okay, let's see it in formatter. I'll clear the previous output. Yeah, so you can see the business entity ID is as it is, but all the first name, last name, middle name, they have gone inside this wrapper. So it has created this name wrapper, and all these 3 columns, they are now nested inside this name wrapper. Okay. Now this is the another option. So these are two options which you can use to convert your tabular data to a JSON data. Right now, there's few more options which it provides. Like one is the root option. Okay, let's see what this root option does. So you can apply another option by comma separated, and with the root you have to give a root name. For example, this is a person table, so we can give a person name as a root. So it will do nothing, but it will just create a root element called person for you. Okay, let's see how it looks like. Okay, so here you can see a top level element has been added with the name person as we gave in our query. So person has been added as a top level element, and inside this you can see there is a square bracket, and within these all our data is structured like this. Okay, so the three records, they have been structured like this. Yeah. Now let's go back to the SQL query. Okay, the other option is include null values. So in our previous example, or the whatever examples that we saw till now, the middle name was present for the first two records, but for the third record, middle name was not there. Let's query this again, and we can see the third record does not have a middle name, right? So the third record is null, middle name. But if we still want to show the middle name with the third record, so what we can do is we can use this option as well, and put it here, right? So you can put as many options by using comma, or if you don't want, you can remove the earlier option that you have applied, right? And even you can keep it up. So if you execute this and the query, you will see I will take you to the SQL formatter window and see. So we have got middle name here as well, but it contains null value, right? So this is the option to contain null elements in your JSON document as well. Okay, then the other option is without array wrapper. Now this without array wrapper option allows us to remove the square brackets surrounding the JSON document. So if we can see here, there are square brackets. So if you want to get rid of this square bracket, or if you want to remove this square bracket for some reason, you can use without array wrapper option. Okay, so let's see this. So it will, okay, it says that the root option and the wrapper option cannot be used together. Let me remove this root option. Okay, and let's see how it works. Okay, so it has given the JSON. Okay, let's see it over there. Okay, now it says that parse lining error because without the because these are multiple result sets. So if we see here, these are the multiple result sets, and multiple result sets are kind of arrays, and they should be within the bracket. With the proper brackets, this would be a proper document. Okay, now let me check this. Yeah, so if you can see, now we have got this back. But yes, if it is only a one result set, then you can consider removing the square brackets. If there are multiple result sets, you should not be removing the brackets. So if this had been just one record, right, like this, then this would have been a valid JSON. So now let's check this. So you can see this is a valid JSON, right? But if it is not a one result set, if there are multiple result sets, right, then these all are arrays, and they should be inside a square bracket. So if you see, we are getting a parsing error, and this parsing error can only go away when we will enclose this document in a square bracket. So if you can see, applying the square bracket validates the JSON. So this is it for today. Today we saw how we can convert a tabular data to JSON data, right, with the auto option and the path option, and with some other options as well. So in the next video, we'll see how we can do the reverse of it. like how we can parse the same JSON document and convert into a tabular structure like a row and columns. So to parse the JSON document or read the JSON document in row and columns, SQL Server provides these two functions. One is the open JSON and another one is JSON value. Okay, so we will try to see how we can use these two functions. So first of all, I'll take the same example in from my previous video where we used person.person table. Let me first of all create a JSON document again by using the previous example. So select top 3 star from person.person. Now I'll replace it with some columns: business entity ID, then first name, then last name. Okay, I'll just take these 3 columns for now. Okay, and it gives us this one. So let us convert it to a JSON format. So for JSON path, okay, then root, and yeah, I'll just give person. So this is the document it has returned. Let's convert it to a proper format. So this is it. So under a parent person we have these 3 data sets. I'll copy them back to here and paste them in my query window. Okay, so here is the JSON document. Okay, I will put it in single quotes and assign it to a variable. So first of all, I'll declare a variable, declare @JSON. I'll just give 1000, then select @JSON is equal to, yeah. Okay, so this is our JSON. So let us see how it looks like. Here select @JSON. Yeah, so this is our JSON document. Okay, and stored in a variable. Okay, now what we'll do is we'll just try to query it by using the open JSON function. Okay, so for that I'll start with the select query and the columns. So the column is business entity ID, comma first name, comma last name, from. Okay, now here we will provide the JSON document inside the open JSON function, and the variable and the root of our JSON, and the syntax is dollar dot person. Okay, now this alone is not going to work, right? Let us try executing it. Okay, so here it is. So it says that it does not know that, okay, what are these columns. So we'll have to use a with clause, and we'll have to provide the columns list with their data type. So I'll copy these. Okay, and I'll separate out. So business entity ID, it is a integer. This one can be a varchar, first name, so 500. Then this is also a varchar 500. Okay, and just give it some alias like person. Yeah. Okay, now our query is complete. So select all these columns that we want to fetch, then open JSON, the JSON variable, and the root of the JSON document, prefixed with dollar and dot. Okay, then with clause, under with clause we have defined these columns. So till now here the columns were not defined, so we have defined these columns with the proper data type and have given an alias. Okay, so let's try executing this query. So I've selected this query and I will execute it. Okay, see, so we have got, our data back into a tabular fashion, so rows and columns. Okay, Now there is one more way we can achieve the same result by using both open JSON and JSON value. So without using this with clause, we can achieve the same. Okay, let me copy this, and probably I'll comment the code, and we'll see here. I'll place all these columns into separate lines because we are going to use the JSON value for function. So here we'll use the JSON value function, and we'll have to give an alias here. So I'll give a alias as p. So JSON value p dot value comma, and just like we gave here dollar dot person, so here also we will just give dollar dot business ID, single quotes and bracket. Yeah. Similarly, we'll have to give the same with rest of them. Okay, JSON value p dot value, p is nothing but p is this, the alias. Okay, yeah, and at the end we'll give some name. So this is ID as f name as l name. Okay, so this is it. What we have done is we have, what we are doing is we are using open JSON function, passing the JSON variable which is containing the whole JSON document, using the same root element, and rather than defining these columns over here, what we are doing is we are using JSON value function, and pointing to this document and using the dot p value. Okay, and with the elements that we want to fetch. Okay, so let's try to execute this query. So let's see. Yeah, so we have achieved the same result, and even if you can try running all these both of these queries together. Okay, and these both will fetch us the same result. Yeah, so if you can see business entity ID, first name, last name, and here the alias are different because we have provided the alias like this, right? And this is the way you can parse a simple JSON and get the results in a tabular format. Okay, in our next videos we'll see some more complex scenarios where the JSON is not so simple like this. The JSON can be a nested JSON, or and the JSON can be a nested JSON with multiple array elements into it. In our previous video, we saw a simple JSON and we converted it into a row and column format by using JSON value and OpenJSON function. So let's quickly look into it. So we converted this JSON into a row and column format. So if you can see, there are 3 records, and if you can see in the JSON, the 3 records here are as like this, but there is no nesting of elements. If you see, there is a root person, and under this root element there are these records which are at the same level. Okay, so let's take an example of a JSON which has a little bit of nesting. So I'll take this example. It's not very complicated, a simple one, but it will give you an idea. So I will store this JSON into a variable, so I'll declare it. So declare @JSON. You can keep any name. Okay, and then we'll store this JSON variable into this particular variable. Okay, now we have this JSON, so it has a order header as a root node. Under this root node we have 2 elements, order ID and customer ID, and rest of the 2 elements are inside the order detail attribute. So you can see here, so there is a nesting. So under this we have a nested JSON. So let's see how we can parse it. Okay, so we are going to use the same functions, open JSON and JSON value. So select star from OpenJSON. So OpenJSON, here you will have to provide first of all the JSON variable from where you have to retrieve the JSON or parse the JSON. Then you have to provide the root node over here. So providing root node goes with this syntax dollar dot and this order header. Okay, now comes the turn of columns. So here we will use JSON value. Okay, and we'll give it a name, let's say as a. Okay, so we will use this alias a dot value. Then we will use the column name in a similar fashion, dollar dot order id as order id. Okay, and what I'll do is I'll copy this. We have 4 attributes, so I'll copy it 4 times. Okay, and I will just substitute customer ID over here. Okay, then product ID over here and unit price over here. Now if we try to run this, okay, let's try running this, it won't give us the values because we are just providing product ID and unit ID, but product ID and unit price are under the order detail, so we have to provide the order detail here as well. So order detail dot product ID and order detail dot unit price, right? So now this will work. Okay, so let's try to execute it. And okay, we have got order ID, customer ID, product ID and unit price 350. Okay, so this is going to work. Now we talked about only the nested of JSON element. What about when you have a array based structure? So right now here under order detail there is only one value, means only one record. What if you have condition like this? So what if you have like this? So this is also valid JSON. So it says that customer with customer with this order ID has 2 products. So product ID, let's say it is 5,000 and let's say this is 800 rupees, unit price is 800 and product IDs. So customer purchased 2 products. Okay, one is this, its price was this, another one was this and its price was 800. Okay, now let's see if we get a desired result. So our expected result would be 2 records of 100, 2000 and the product IDs, right? So these will be repeating and these will be unique. So 2000 and 5000, unit price 350 and 800. So let's see if we get the result or not. Okay, so okay, no, we have just got null. Okay, why we have got null? Because just providing this product ID, it will not get an, because now it is an array. So this order detail is an array, and just by giving product ID and unit price, it won't know which element it has to pick. It won't get the pointer, right? So what you have to do is you have to provide a array position, which position you want to pick. So by giving 0 it will pick up this, by giving 1 it will pick up this. Let's just test it. Okay, so it has given 2350. Now what about 5800? We cannot give like this, right? Because if we'll give 1 then we'll lose other one. So in this case we might have to repeat these columns. Okay, so I'll repeat these columns, give them 1 1. Okay, so I've changed the alias as well, so they should not conflict. Now let's see what should be the result we got. So product ID 2000, product ID 5000. Okay, so we have got both the products. Now what if it has a third element as well? So what if the customer purchased third item as well? So third item is like 9000 and it is like 200 rupees. Okay, now here you'll have to again add it. So because customer would be purchasing more products, so you won't be adding columns in runtime, right? So there should be some approach where you don't have to provide these extra columns every time. By just doing something over here, it should be picking all these orders in one go without even providing hard coding all these things here. So SQL Server provides a window function that is cross apply. Okay, so we can use cross apply function over here. Okay, now let's see how we can use it. So cross cross apply, right, and cross apply, then open JSON. And now exactly what we are doing here, is, first of all, we are taking order ID and customer ID with only with this JSON, right? And then we are expanding these attributes with this open JSON, right? So what we'll do is we'll point it like this: a dot value. Okay, a dot value, and we will put order detail over here. So order detail will go inside here. Okay, dollar dot order detail. Okay, and we'll alias it as b. Okay, now rather than putting here as a, we will put it as b, because now we are not going to get data from this particular node. Okay, so what we are doing here is, by using cross apply under this order header, we are trying to point to this value, and we are trying to go to this particular node and expand this node. Just like the way we have expanded this node, we are going to try to expand this node. Okay, so order header, if you see, order header contains order ID and customer ID. So we are just going to parse open it by this particular JSON. So we have aliased it as a. So a dot value, okay, with order ID and customer ID, and this order detail we are going to parse it over here, right? So this a dot value we are going to give here, and inside this a dot value we are going to parse this order detail as a separate JSON function, and we are going to give it as alias b. And if you see, b dot value, okay, like this, and b dot value like this. Now we are using a separate method to expand it. We can remove the order detail reference over here. Okay, so what should be the expected output over here? So we have these three orders for this customer. We will be getting three rows having these three unique values, and the order ID and customer ID should be repeating. Okay, let's execute this query. Okay, yeah. So if you see, order ID and customer ID are repeating three times, but your unique products, three products, we can see here with their unit price, right? So this is a very easy way to go into a nested structure by using the cross apply window function, right? And then again using a open JSON function, and expanding the internal attributes of this particular child nested element. Okay, in next video we'll talk about more scenarios with JSON. Today in this video we will see how we can store a JSON data in a SQL table. So in my previous videos, we saw how to convert data from a SQL query to a JSON string, and in another video, we saw how to do its reverse, like how to convert a JSON data back to a SQL row and column format. Now we will see how we can store this data permanently in a SQL table. So for doing this, we will be using the same OpenJSON and JSON value functions that we used previously. And there is another function that SQL Server has provided, that is JSON. This function we have to use while creating a table as a check constraint. Okay, so let's see how to do this. So first of all, we will be creating a table. I will create a table by pointing to this database, because I'll be using a sample data from this database as well. So use AdventureWorks 2019. Okay, now we are using this database. Now I'll just create a table. I'll put it the customer order. Okay, so what I'll be doing is, I'll be using the person table and the order table. So I'll be pulling some columns from the person table. Okay, we can check here as well, Alt F1, so it will give us the columns that are used by the person table. So business entity ID, okay, that is integer. Then the first name, okay, I'll make it varchar 50. Let's make it an varchar. Then the last name. Okay. So three columns, and then the customer order detail I'll try to put. So what is the customer ID and the customer name, and what are the order details that he has. So I'll name this column as order details JSON. So we are going to insert a JSON string here. So that's why I've put a suffix of JSON here. And storing JSON is simple in SQL Server because JSON is nothing but a string. So we can use nvarchar, right? And I'll give a size of 1000, and so we can use nvarchar data type to store this particular data, right? Now you can store this JSON, right, in this particular function. But what about the validity of the JSON? The JSON that you are going to store, is it valid or not? So to validate it, we will add a check constraint. So check constraint, then we will use this particular function is JSON, okay, and on which this column we have to apply this function, right? So is equal to 1. Right. So is equal to 1 means that this function will validate whatever the JSON data is going to store here is a valid JSON. Should not be arbitrary a character or a string. Okay. So I'll remove this person. Okay. Now our table is created. Our table script is created. I'll execute this. Okay, yeah, so we are done with our table creation. Now what I'll do is I'll just create some sample data, right? So for creating a sample data, I'll use the person table. Okay, so first of all, select from person, then I will pick the columns. So business entity ID, comma, first name, then comma, last name, and here we will create a JSON which will in square brackets. Okay, so here we'll get the JSON, and to get the JSON we will use the sales order header. So there will be a sales order header table. So yeah, we'll pick this table, okay, and select from sales order header. And sales order header, what all columns we have in sales order header? Let us try to see. Alt F1. So these are the columns. So I'll pick sales order ID, then order date, right? Then let's say what all things we can pick. Let's pick the subtotal, okay, and tax amount, okay, and last column total due. I think these columns should be enough for us, okay. And so what I'm doing here is at a column level I'm trying to give a subquery, right? So why we are giving a subquery, you will understand it here, where, right, I'll try to give an alias, okay, s dot customer ID is equal to we have this as p dot business entity ID. Okay, so let's see how these records look like. Okay, now we cannot execute this query like this because this is one row, and for one row there can be a possibility there are multiple rows in the subquery, right? Now to make this work, what we have to do is we have to create this as a JSON. right? Now to create this as a JSON, we'll convert multiple records into a single value, single string, right? So we'll have one row of JSON containing multiple records from the sales order header. So for this, what we'll do is we'll use for for JSON auto. Okay, so for JSON auto will get us single record, and this will execute without any issues, right? So why this happened, why it failed in, in first go? Because for example, if you take this, right, so this particular customer has only one order, okay, but this particular customer, if you see, right, it has multiple orders. So it has first order is still here, right? This is the second order, sales order ID is this ending with 50, and here sales order ID is this ending with 99, right? Now if you apply a subquery in a select statement, means in the select statement with other columns, it should only return one row. If it returns multiple rows, it cannot align with the other columns, other rows, right? So that's why it failed in one go. Now why it didn't fail now? Because now we have converted multiple rows into a single row of a JSON string. Okay, now it is a bit easy for us to put this here, right? And what we can do is we can wrap it inside a CTE. Okay, so I'll just put this as CTE. Okay, and after this, insert into so our table name is customer order. So insert into customer order, I will select all these columns. So I'll copy the columns list, select business entity ID, first name, last name, and this one from our CTE, where I don't want these null columns, so not null, right? So let's remove and check this first. We are not inserting, I'm just querying the CTE, so it will give me only the results where customer has ordered. Right now we will apply the insert statement. Okay, so insert statement, if you see, yeah, okay, now it says string or binary data would be truncated because there is a possibility where we have taken smaller names, smaller length, or there might be a possibility where our this envar this 1000 is exceeding. So what we can do is we can try to put max. Okay, so I'll drop the table, drop table customer order. Again I'll create the table customer order. Okay, by giving max, it can contain data up to 2 GB. So if a customer has multiple orders, okay, those will still be stored, so the limit won't be limited to 1000. Okay, now, okay, 9778 records got inserted into this table. Now let's see, now let's check this table customer order. Okay, so we'll just try to query this particular table, select star from customer order. Okay, see, now we have the records, right? Every individual, with every individual we have these customer orders, right, in a single row. So some customers will be having multiple orders, right? And if you can see, these are having multiple orders, but still we are able to maintain them, store them in a single row. Okay, this is what JSON gives us benefit. In this video, we will see how to query the data directly from a table into rows and columns. Okay, so what we can do is I will be just giving this alias as customer order CO, and CO dot business entity ID, CO dot first name, CO dot last name. Okay, and these are JSON strings. So in our previous video we saw if we have to get these JSON, so we can use the cross apply function. cross apply and open JSON. So with open JSON, we'll have to give the column name over here. Okay, first of all, we'll give the column name. Okay, and so we have given the column name, and then here I'll give an alias as well. So as this also I'll give as an alias as X. So this will go as JSON value, okay, X dot value, comma, within this it is sales order ID. Yeah, it is sales order ID. It's a dollar dot, and I'll give it the alias as sales order ID. Okay, now let's just run for this particular only. Yeah, so we can see, we have got the sales order ID. Now let's pull some more columns. Okay, then this is order date. I think we can pick it from here. Order date, and let's pick only total due, right, rather than picking all the columns. So we are just picking only 3 columns. Okay, now let's just query this. Okay, and we can see some of the customers which have 2 orders have split it into two records, right? Because this guy who has uh, ID of 16902, he had 2 orders, so this 2 orders have been split into 2, right? So this is the sales order ID 1, this is sales order ID 2, and this guy also has, split into 2, right? Yeah, so whoever plays multiple orders, like this guy, he has 3 orders, so we have got 3 orders in 3 different rows, right? So this is very easy to query the JSON data back from the column, from the JSON column where we try to store the JSON data back, right, here with the above approach. So this is the way you can store a JSON string into a table column, and also validate the table column. You can also validate the table column by using this check constraint is JSON. And after that, if you want to retrieve, if you want to query back this data, you can also do the same thing by using some of the functions that SQL Server gives, like cross apply, right, then open JSON and JSON value functions, right? So this is the way you can query the data back. So this is it for today. I think you would have liked this video. Please let me know your comments and suggestions, and thank you for watching this video. Please like and please subscribe. Have a great day. Thank you.